Hi guys, BuildZoid here, and today we're just going to take a quick look at the VRM settings on the MSI Z690-A DDR4 motherboard. So right now I have it with the lowest possible VRM switching frequency and with the LLC completely maxed out. So we're at mode 1 LLC and the core voltage is set to 1.18 volts. And we're going to run a little bit of Prime95 and basically see how much undershoot we get. So we're going to run small FFTs, and then we're going to move the mouse around, because basically the worst transient I've been able to reliably produce is running Prime95 small FFTs, which is a very high current draw workload, and then moving the mouse, which basically interrupts the workload of Prime95 running, which causes a massive amount of overshoot, and then once Prime95 resumes, the voltage undershoots quite significantly. So anyway, let's take a look at that, shall we? Oh, that's Prime95 running right now. The oscilloscope is hooked up to the back of the motherboard, like the back of the CPU socket, so obviously our voltage is not going to stay the same as it was at idle. And then if I move the mouse around a bit, yeah, we start getting some undershoot there, right? Down to like 1.15 volts. I've gotten it all the way down to 1.14 a few times, but okay, I guess we're not gonna catch one that low right now. But yeah, so right now we're getting 1.15 volts, and that is with the load line calibration completely maxed out and the switching frequency as low as it'll go. So I'm just going to restart this, and we're going to max out the switching frequency, because that actually helps quite significantly with the voltage regulation on this motherboard, which is pretty interesting, because on most motherboards it doesn't really make a difference. Then again, this motherboard isn't using, like, a lot of the motherboards where I'm used to this not making a difference, you know, we'd be talking about like International Rectifier or Intersil or Renesas voltage controllers. But this board uses a Richtech voltage controller. So if we go into the digital all power, you'll see that, yeah, I have load line calibration mode 1, right, which is the least droop on an MSI motherboard. It works in reverse of how Asus does it, but it's actually the same as how ASRock does it, right? ASRock level 1 LLC is the least droop. So anyway, then we have overcurrent protection enhanced, and then switching frequency at 238 kilohertz, which is as low as it goes. If we go up to 677 kilohertz, it'll actually significantly improve the voltage regulation, as our minimums should not be able to dip below 1.17 by just cranking up the switching frequency. So that's pretty neat. And hopefully the capture card is not going to cooperate. Lovely. I've finally decided to buy a replacement capture card. I've had it with this one. Okay, so let's get our hard. Well, actually, I don't know why I bother with opening hardware info. It's not like it matters. Like, it's not like we're really worried about the CPU temperatures when we're just doing these quick little tests. I'm just going to zoom the scope out to reset the monitoring metrics. So previously, and like, it's worth noting that right now, you know, we have a 1.15 minimum here in idle, but that doesn't really matter because the CPU is not going to crash while it's not doing anything at idle. So yeah, let's start small FFTs. Voltage goes up to 1.22 volts. I'm just going to zoom in a bit. And now, if I move the mouse around, you'll notice that instead of, you know, hovering around that 1.6 down to 1.16 down to 1.14 volts range, the minimums are only going as low as 1.17. So that's quite an improvement in terms of voltage regulation. So yeah, that's pretty neat that this motherboard actually cares about the switching frequency. Now, you don't have to max it all the way out, but the VRM on this board really doesn't have any like issues in terms of operating temperatures if you have halfway decent airflow. So I really don't see a reason. I don't really see a reason to not just max out the switching frequency. So yeah, anyway, now the disappointing part with this VRM is that you don't really, like, you need to add a lot of E-droop before you get another improvement in terms of minimum voltages. So right now in mode 1, with the maxed out switching frequency, our worst case scenario, like, undershoot is 1.17 volts. with an RMS voltage of 1.22 volts. So if I wanted to improve on that, which, where did my notes go? Oh no, where did I put them? Wait, did I close them? Am I that stupid? No, I didn't close them. Oh, they were under the capture card controls. Anyway, so yeah, if we want to actually get a little bit of an improvement in like another improvement in terms of minimums, we need to go all the way up to like mode 5 or all the way down to mode 5 V droop, which is quite droopy as we are going to be adding a whole 105 millivolts to our core voltage in order to get the same load voltage, right? Because all of the extra V droop that we're getting. Now this is still totally usable for daily, right? Because these chips are relatively hard to cool, so yeah, I don't see this as a huge downside. In fact, if like I'm thinking I have an idea for some experimenting with some overclocking on the 12th gen chip that isn't just like setting the same core clock to all of the cores. And so for that, you might actually have benefits, like they might actually be beneficial to just have a really droopy LLC in general. So yeah, anyway, there goes the capture card again. And let's do small FFTs. So obviously right now our idle voltage is higher, but you know, that's not a problem. CPUs don't degrade at idle. Well, they can, but you need a hell of a lot more voltage than just, you know, like even 1.4 volts is going to be completely fine at idle. So anyway, now we're under load. Our RMS voltage is again 1.22 volts, and I'm just going to reset the monitoring. And now if I move the mouse around, we hover around the 1.19 to sort of 1.18 minimum voltage range, right? Our average minimum voltage is, well, the average minimum voltage depends on how much I move the mouse around, but the absolute minimum voltage is now 1.18 instead of just 1.17. So that's a slight little improvement that we can get. And then the next improvement happens at mode 7 LLC. So, yeah, that's kind of how this board behaves from my testing. So, just going to restart. So there we go. So we've restarted, and now we're gonna go up to mode 7. Now this one is, well, again, depends on what how you're setting up your overclock, but at this point we need a lot more voltage than in mode 1, as we need all the way up to 1.34 volts in order to still get that same 1.22 volts RMS voltage under load. But we should see another 10 millivolts improvement in, like, undershoot. So, yeah, which, like, the issue here is like, back of socket measurements are not good for comparing different motherboards against each other. Because each motherboard socket will be configured differently, and the resistance between the socket and between the back of the board and the CPU socket is going to be different. And so, you know, not really great for comparing different motherboards to each other. But what I do find interesting with this board is that, like, there's not much improvement going through the you need to go really far down the LLC before you get some significant improvement in undershoot. So, and I don't know why I keep trying to open hardware info. Like, it's not going to help us right now. Though we will take a look also at the VCC sense versus socket sense on this board. So anyway, small FFTs, RMS voltage drops all the way down to 1.22 volts. And then if we start moving the mouse around, right, we're hovering around, okay, it's a little bit high. It's at 1.23 right now. So, might have, like, basically I need to set the voltage a bit lower. I'm just going to quickly do that. Shouldn't be any issues. Yeah, okay. So we're just going to go down to 1.33. Hopefully that should get us close enough to 1.22. But yeah, so overall, I think with this board, you probably want to, you want to definitely run one of the higher switching frequencies. I guess it would also be worth checking what the board does on auto, so we'll do that as well. I don't really have too much of a plan for this video. So, okay, let's pull up Prime95. Come on, stupid capture card. Yeah. Oh. Okay, now it works, finally. So Prime95, small FFTs, and we're down to 1.22 volts. I'm going to reset the monitoring data, and now we're just going to wiggle the mouse around. And now instead of getting, 1.18 minimums, we're getting like 1.19 minimums. So another 10 millivolt improvement for, what is it, like 40... No, that's like 55 millivolts more voltage. Nah, 65. Well, yeah, so basically more, you need to have more idle voltage, but your load, like your voltage regulation improves a bit more. Anyway, that's kind of that. I guess we could take a look at the, so now we're going to take a look at what happens with auto switching frequency, because I do actually wonder. Though we're going to go all the way back to mode 1, LLC. Because that's where you're going to see the most impact from that. I kind of wonder what auto LLC does, but yeah, and then I'm going to set this back to auto, and we'll see if we get that, if we get 1.17 minimums, then obviously it's not running the lowest possible switching frequency. I do wonder why MSI would include the option to potentially make the, oh wait, oops. Okay, we need to restart. Because, obviously I didn't change it, I didn't set the voltage. Yeah, trying to run Prime95 with 1.3 volt, 1.34 volts and no V-droop would be a very bad day. I have a 240 millimeter AIO on the CPU right now, and that would not be a good thing. It would not be pleased with that, whatsoever. So, yeah, back down to 1.18. All right, capture card. There we go. Now we're going to do small FFTs again. So we go up to 1.22, and then, yeah, so the auto switching frequency is not great. Right, you can see it dips all the way down to 1.116 volts. So you probably want to set it manually to 605 or 677. I'd probably I'd go to 677. The VRM really doesn't have a cooling problem, so just maxing out the switching frequency in this case, because it does help. Right, there's a lot of motherboards where you can max out the switching frequency and it just doesn't make a difference, but here it definitely helps a bit, so I'd say it's worth it to just max it out. And now we're going to take a look at the socket sense versus the VCC sense, which all that does is change the voltage readings in your monitoring software in Windows. So, oh yeah, so now we're going to need hardware info. And we can do it at the mode 1. Actually, we're going to do it with mode 3. There. I'm going to go up to 1.23 volts. I'm going to go to mode 3, and I'm going to max that switching frequency right back out, because why not? And I guess I could take off the transparency effect at this point, or maybe just remove the oscilloscope. Well, no, it's worth seeing the oscilloscope, but the thing is, like, there's no difference. Because I've already tested this. On some past motherboards, the MSI motherboards, the VCC sense versus socket sense thing did some weird stuff to the, like, load line calibration, but that at least on this board, that doesn't happen. So I don't know if that's true across their entire lineup, or if it's just with this board that this is no longer a thing. Where's my mouse? Okay, I should... You know what? I'll just hide the oscilloscope overlay. Nope, that's not the oscilloscope. This. And that. There we go. Much better. So it's a bit dark, but, you know, I guess if you're watching on your phone in a dark room, or if you're watching in a dark room, I guess this is kind of nice instead of having everything be 100% white. Okay, so we're going to scroll down to our V-core, and right now it's reading 1.23 volts, and it's accurate right now because we're at idle. Right, at idle, there's not going to be a big difference between measuring somewhere on the motherboard versus measuring at the actual in the actual CPU. And now if we run small FFTs, the voltage drops by 30 millivolts. But it is not dye-sense, right? Because, well, I'll show you when we use mode 1 LLC, because the thing is, in mode 1, the voltage actually goes up. So it's not true dye sense voltage. It's better than socket sense voltage, like it's closer to dye sense than some other measurements, but it's not actually dye sense voltage. So anyway, yeah, that's Prime95 running right now, 1.2 volts, and we're just going to stop all the workers and then restart, and we're going to switch over to right now I think we're in VCC sense, right? I guess we'll find out when we get to the BIOS. Like, it really doesn't matter. All it does, like, the nice thing is it does only change your, like, voltage readings. So, yeah, so right now we're in VCC sense. If we go to socket sense, we will actually see the voltage probably climb up a little. Yeah, I think VCC sense, I mean, socket sense, I think we're going to see the voltage go up to 1.23 volts in Windows. It's... The actual, like, CPU voltage is still going to be the same because we're just changing where the motherboard is, like, measuring the voltage. We're not changing... Like, the VRM still measures the voltage in the same place. Because the thing is, on Intel motherboards, you don't actually get a voltage reading directly from the VRM controller. You get your voltage reading from the Super I/O. And the Super I/O is... Well, usually it would be hooked up to, like, back of the CPU socket. Which is not a super, like, because the idea behind the Super I/O voltage sensors is that they're supposed to give you a rough idea of if the voltage is roughly where it's supposed to be. They're not meant to be, like, super precise. So that's, like, they also don't have a whole lot of resolution, generally speaking. So, anyway, if we go over here, like, if we look at the details for that sensor, right? You'll notice that this is a Nuvoton NCT something whatever chip, and that's a Super I/O chip. That's not the actual VRM controller on this motherboard. So yeah, anyway, so right now our idle V-core is, you know, slightly higher than before, and then we hit small FFTs, and our V-core actually ends up going slightly up. In fact, it's above what we get on the oscilloscope. Which is kind of interesting because the oscilloscope is hooked right to the back of the socket, so I guess this must be hooked up even further away from the CPU socket. Like I'm measuring across one of the multi-layer ceramic capacitors inside the CPU socket, so the fact that this is going up is kind of like, I wonder where that voltage sensor is. Like, yeah, I wonder where that measurement is coming from, because it's weird that my oscilloscope is measuring slightly lower voltage right now than that sensor is, but... Anyway, yeah, so that's the difference between dye sense, I mean, it's not dye sense, between VCC sense and socket sense. And the reason it's not dye sense is I'm going to show you right now, because we're going to switch over to mode 1. I'm going to set it to 1.18 volts, and it is not going to be 1.18 volts. And the voltage controller is perfectly capable of hitting exactly 1.18 volts on the CPU. In fact, well... The thing is, the voltage controller is unfortunately under one of the VRM heatsinks, so while I could connect to the... well, basically I didn't want to go through the hassle of connecting directly to the controller's sensing circuitry, because that's not fun. Like, it's not impossible to do, it's just not fun to do. As in, it's, like, really tedious, and all of the components are really small and rather fragile, so if you attach big, long wires to them, it has a tendency to rip them off the motherboard, and then reattaching them, depending on... And the thing is, if you rip those off, they normally take the pads with them, and then it's just like, yeah, you know, I'd rather not deal with all of that. Wait, did I actually remember to switch it over to VCC Sense? Well, I guess we'll see, right? Because right now, it's either gonna... Either in hardware info, we're gonna see it go all the way back up to like 1.24 volts, or it's gonna go up to 1.2 volts, right? Oh man, this capture card. I can't wait for its replacement to show up. Hopefully the replacement is better. Like, the capture cards, in my experience with... Like, this is not the first capture card I've had. My experience with capture cards is that they don't really appreciate like resolution change, constant resolution changes. I think we're still on socket sense. And yeah, okay, so indeed we are still on socket sense, but you can see that, okay, so, you know, in mode 1, in order to get the same core voltage, we obviously need to, we need less set voltage than in mode 3. So yeah, so we're still on socket sense, and now we're going to switch over to VCC sense, not die sense, because if it was die sense, we wouldn't see the voltage. Like, you shouldn't see, the average voltage shouldn't change at all. So yeah, now we're gonna go all the way to, well, no, not going anywhere. We're going to VCC, we're switching over to VCC sense. And the capture card. There we go. Oh, nope, it still hasn't started responding. Come on, there we go. So now at idle, we should be sitting at like exactly 1.18 volts. And then when I press run on Prime95, it'll actually go up a bit. Yeah, so we're at 1.186. You know, there's obviously going to be some margin of error. So, you know, 6 millivolts, yeah, that's fine. But this ends up going slightly over 1.2 volts, and that's just kind of like, that really shouldn't be happening. So, yeah, it's a lot more accurate than, you know, the socket sensor. But this, I don't believe, is comparable to the voltage measurement you would get from, like, like an Asus Maximus board where they have die sense, or to the voltage measurement that you would get from a Z690 Tachyon, which also has like a proper die sense voltage sensing implementation. Yeah, it's better than, like, it's better than socket sense at the very least. Like, it's not off by, like, it's not completely way off, right? Like, it's pretty close. It's probably off by, I don't know, 15 millivolts or something. Maybe 20-ish. You know, maybe 25, something like that. So it's really not doing too bad a job. And yeah, but it is not die sense. So you can't just like if you take a CPU off of this MSI motherboard and go like, oh, in VCC sense, this CPU needs 1.2 volts to hit 5 gigahertz on this MSI motherboard, and then you take this CPU and you put it in a Asus motherboard, and you're sitting there wondering why it needs less voltage. It's because the sensors don't work exactly the same way. It's not because the one board is actually like, well, actually, considering the voltage regulation that we've seen with the whole like Prime95 mouse test, that would actually potentially make a difference. But especially if you're comparing like mode 1 on this board against, say, level 4 LLC on Asus. If you were just going by like Cinebench performance, because Cinebench is super easy on the VRM in terms of just voltage regulation, so I'll bring the oscilloscope back, right? So if I run Cinebench, right? Like, it really is no big deal. I can move the mouse as much as I like, and it's not anywhere near as bad as Prime95 because the Cinebench is just not as intensive a workload, so when Windows interrupts it, it doesn't cause such a massive amount of overshoot, and then also it doesn't cause as much overshoot when it ramps back up to well, running, right? So yeah. Anyway, so we're just gonna stop Cinebench. That's kind of that. So basically with this board, definitely I'd say max out the switching frequency for the VRM. There's really, like, I can't see a reason not to do that, considering the voltage regulate. Like, it does actually help voltage regulation on this board. And then for the actual LLC settings, I'd say you probably want to use, like, I think I'd probably use, like, mode 5, maybe 7, depending on, you know, how much cooling you have and that kind of thing. Mode 6, well, like, it's really strange that there's not, like, what I find super strange with this board is that mode 1 and 2 have basically the same performance, and so does, like, 2 and 3, and, like, you need to really add a lot of E-droop before this motherboard sees any improvement in voltage regulation, and I do find that rather strange, because on most other motherboards, like, the last two, like, the equivalent, like, the gigabyte equivalent of mode 1 and the gigabyte equivalent of mode 2, there's a pretty big performance difference between them. On this board, there isn't. And that's, you know, I do find that rather strange. Yeah, also these are like back of socket measurements, so they're probably not that accurate. Yeah. So it's kind of that. But definitely, I'm confident about the switching frequency thing. That is reliably definitely one to max the switching frequency out, in my opinion. But the LLC, like, well, mode 5 seems to be a good, mode 5 seems to be a good spot, because if you use mode 4, it really doesn't, like, it doesn't really give you any benefits, right? You need to go up to, like, 1.26 volts, and I guess, and screw it, we'll leave it on VCC sense. It really doesn't make a difference. And we're going to do one last Prime95 test, just to show that there really isn't a difference between, like, mode 5 and 4. Or more like that 4 and 1 basically perform the same, so that 5 is actually better than 4, but also my scope isn't the most sensitive thing in the world, so might be part of it, but also, like, less than 10 millivolt improvements are arguably not really worth the effort. Alright, come on, capture card. There we go. Let's run that Prime95. So RMS voltage is again 1.22 volts. I'm just going to reset the monitoring, and then if I move the mouse around... Oh, mode 4 is apparently fine now. Man... I have notes that very clearly say mode 4, RMS 1.22 volts, absolute minimum 1.17. And then it's like, and now let's do it on camera, and it doesn't. So I guess mode 4 is also probably viable. I don't know why it didn't do this in my previous testing. Okay, so now we're gonna have to do like a sanity check, I guess. Let's try mode 3. At least this isn't like a super time-intensive test method. So mode 3 should require 1.23 volts. Mode 3. And the capture card is misbehaving again. And some more. And still can't move the mouse. Love. There we go. So there. That's 1.22 volts RMS. Okay, so this does actually behave the way I expected to, right? Like that's going down to 1.17. So at least one part of my notes was correct. So mode 3, I guess, is... So mode 4 or 5... Yeah, so mode 4 or 5... Basically, I wouldn't use mode 3, 2, or 1. Right? Like, those are definitely giving you more undershoot than necessary. And I guess if you're going to use mode 3, you may as well use mode 1. I think, like, for daily, I would probably go with mode 4, 5, 6, or well, basically with the lower half of the available LLC settings, right? Not much more to it than that. And the thing is, like, really the only reason to use a less droopy LLC is because if you need to set your idle voltage just insanely high to get the load voltage that you need. But with 12th gen, I don't really feel like that should generally be like much of a issue, because 12th gen CPUs get insanely hot if you run like all core AVX workloads on them. So, you know, having a lot of E-droop is really not gonna, like, it's not gonna be a massive problem, because you can't really cool more than, say, 1.25, maybe 1.3 volts if you've got a custom loop, right, in heavy workloads. So, yeah, it's kind of that way. I have MSI Dragon Power installed. I want to quickly try something. We're going to quickly try max out Cinebench on this board. So this CPU should go up to 5.2 gigahertz with enough voltage. So we're going to go up to 1.35. I'm going to have to change the positioning on the oscilloscope. And I do want temperature readouts. Okay, so we're going to pull up hardware info. 1.35 volts should be enough for 5.1, I think. Actually, maybe I should try this at 5.5 first. So, 5, there we go. We're going to scroll down, because if it gets too hot, it'll crash. That's the main, like, that's really the main issue with 12th gen, is it's very temperature sensitive. We had some really nasty spikes when Cinebench was starting there. So, yeah, okay. Moving the mouse right now. Okay, that doesn't cause any issues. But I want to take a look at... Okay, you know what? Mode 4 is probably a good idea. Mode 5, or like mode 5 or 6 even. That is very interesting, because on most motherboards, like, the start of Cinebench is silent. I'll have to do more testing on that, I guess. Then again, I'm not necessarily... well... I guess there might be other workloads that might behave similar to the beginning of Cinebench, and those would crash potentially. Right? Because basically the problem you run into is, like, is your voltage high enough relative to how much work the CPU is doing? If the CPU is not doing much work and the voltage is really low, it's probably not going to crash. If the CPU is doing a lot of work and the voltage suddenly drops out, like drops really low, you have a problem. It's going to crash. Like, that's when it's going to, like, blue screen. So, yeah, anyway. I think at 1.3... Okay, let's try 5.1. Because I think, just looking at the temperatures, I think we're high enough voltage at this point that it should pass. I guess we could also try this with a even droopier LLC. Like we're gonna take a look at the start of Cinebench with more V-droop. Yeah, so that's 5.1 easy. Can I not change the BCLK on this board? Looks like I can't because I have. Yeah, okay, looks like I can't change the BCLK. So let's try 5.2 with 1.36. That's going to be interesting. I have my doubts about that being doable. Like this chip should do up to 5.2 for Cinebench, and then, well, that's it. Well, actually, no. It would probably do more if I had more cooling, but I'm on a 240mm AIO, and so that's just not enough. Okay, so this will pass. It's getting quite hot, but it'll still pass. Yeah, so that still passes. Cool. More than 5.2 is not going to pass. What I do want to see is the start of Cinebench, but with like more V-droop. Also, I think I was running way more voltage than necessary for Cinebench, because those temperatures were quite high. Anyway, I'm gonna try this at 50. No, I said 50. That's not 50. I'm gonna go to like 1.4 volts and mode. That's gonna give us. It's not gonna get mode 7's not gonna give us very much voltage. Well, 5 gigahertz would probably pass. Let's try mode 6. Oh no, I need to like do it with like RMS voltage normalization. So this is not going to be a super useful test. Because the problem is like you need to match the average voltages, otherwise you're not really getting any useful data. Because if you literally just go by like generally speaking, the increase in average voltage due to a higher LLC level is typically big enough to outweigh the like voltage regulation disadvantage that you get. Also, no, not Prime95. That's not going to run. More like that's going to immediately overheat the CPU. It might actually run, but not enough cooling right now. Scroll down a bit. Yeah, so there's just like big dips right as Cinebench starts. And also, yeah, the RMS voltage is way lower right now. So we'd need to be like over 1.4 volts in order to make a comparison. The thing is, I don't think... So actually what I want to do, because I have thought this through, because you basically don't want the voltage, like when you don't want the downward voltage spikes when the benchmark is starting to be lower than the load voltage, right? That's like be significantly lower than the load voltage. And it dips down to, so, right, like our minimums right now from this capture are like 1.31. So just kind of, well, actually, wait, is that, nah, let's reset it. 1.31, yeah. And if I just run it, then right now our, so actually that looks pretty well matched, right? Our RMS is down to 1.32 volts. So I have an idea. Let's lower this a bit more. I'm going to drop that down to 1.29. Single. And it doesn't trigger. Cool. So I'm going to try it at 1.3 volts. Okay, so that caught something. And man, that is really strange. Like, I'm not used to seeing anything in from Cinebench. So overall, yeah, I'd say this VRM seems a bit slow. But I'll have to. Like, the thing is, I don't really want to like compare a bunch of different like. I don't like back of socket measurements for direct motherboard to motherboard comparisons. So, like, I have a method for doing direct like motherboard to motherboard comparisons that is, as far as I'm concerned, accurate. But this right here is just kind of like, yeah, this is not it. And I need extra equipment. Well, basically, I need a sacrificial CPU to use the other method. And unfortunately, I can't use this 12900K for that. But anyway, yeah. So definitely, you know what? I think I'll go back to my initial statement of like you should probably go with mode 5, 6, or 7. Maybe even mode 8, but I feel like mode 8 is so droopy that your idle voltage is going to be at like 1.5 volts or something, which I personally wouldn't be comfortable with. Yeah. Anyway, that's it for the video. So thank you for watching. Hopefully you find this somewhat useful. And yeah, like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. Yeah, that's it for the video. So thanks for watching, and goodbye.